Hello and welcome, Sanjin here, and the tutorial you are about to watch is from my Computational Thinking in Python course. It seems to be presently on sale at Udemy, but you could have it for free. Yes, totally free. All you have to do is solve the upcoming challenge, either in a different way from what I did or in a more efficient way. So, have fun with it. And all you need to do once you solved it is post it in the comments, and I'll send you a free coupon. Later! So, the challenge here is how to create unique looking clouds using Python and Turtle. Now, this is a problem with an infinite number of possible solutions, and what you're looking at is just one. This program has the turtle go create semicircles of different sizes with somewhat random turns, and once the circle is complete, it creates a unique cloud. This program here just creates dots in clusters of random sizes, and those look like unique clouds. Can you come up with something different? I sure hope so, and I look forward to seeing your solution in the comments. So coming up is a more detailed look into one of my solutions. Hello and welcome. Now this is the second more advanced solution to the cloudy sky problem. And here's where we're going to create a cloud as a series of semicircles that closes in on itself and then paints the cloud on the inside. So, first things first, I'm just going to create a little bit of a demonstration of how this is all going to work. I'm going to create a function that's called a semicircle, and we're going to have semicircle is going to have a size, and we can call it for I in range. So we can have we need to turn 180 degrees. So if we loop it 20 times, there's going to be a turtle turn, turtle dot left 9, which makes 180. And then we can also go turtle dot forward in proportion to size. And once that's done, I think that should be a semicircle. I mean, I'm just going to call it here. Semicircle, and we're going to make it 5. Let's see what that looks like. Yep, we needed... That's why my indenting had to be done manually. Cool. That seemed to work, but it wasn't leaving a trace. Because... I guess we could put a pen down to begin with. Turtle dot pen down. Okay, there we go. Semicircle. And we can then do a series of semicircles. Yep. And he's going to keep going in circles, so we need to basically, at the end of this function, reset him. Turtle dot... It doesn't matter whether it's right or left. The 180 degree turn means facing in the opposite direction. Cool. Now, if we... adjust this. I mean, if we have this adjust turn function here, and we just turn a little bit more, a little bit extra to the left, and I'm going to show you what that's going to look like. Def adjust turn, and you know, I'm just gonna leave it with no inputs, and we're gonna go turtle dot left. I don't know. We're gonna do 10 degrees. And what I think is going to happen is that this guy is going to start wrapping. Yep, he's going to start wrapping himself. And maybe if this was 20, or maybe even 30, and that was 25, yeah, you have something like a cloud. And so imagine this is going to be, you know, imagine this is your cloud here. So we can have turtle dot begin fill, and we can have turtle dot end fill down there. And 25 was probably a bit too much. Great. So, given the fact that, you know, obviously this is not what we're looking for. We're looking for this thing to look like a cloud, not like a puff. But it's a good start. It's a very, very good start. So if we were adding an element that after each semicircle, we should do something called home check. And that's simply going to say that the turtle checks how far it is from the origin and then closes in on the origin. So def home check, what can we do? We can say distance equals to turtle dot distance to 0, 0. And then say if distance is less than 50, turtle dot go to 0, 0. And then we can end fill. Turtle dot end fill. And the plan here is that when the turtle gets close to done, yeah, it will do the fill, but it'll keep on running. And the question that I'm wondering is what we can do for the turtle to actually stop drawing the cloud. Well, I'm just I'm just thinking we could have something like a boolean, like cloud finished or something. Cloud done. Cloud done equals to false. And so when we start drawing a cloud, I'm just going to call this a cloud. And I'm going to say cloud done equals to false. So when you start to draw a cloud, the cloud done is false. But when the this is done, then cloud done equals to true. And since we're referring to the same cloud done, I believe I have to go and call this global cloud done. This is really, really important and somewhat clunky in Python. But if you want to refer to the same variable from different functions, you have to declare the variable in the general set before any functions have been created, and then you have to reference it inside every function by saying you're using the global cloud done. So instead of 25, we can now say while cloud done equals to false. And, oh, double equals to. Thank you, Python, for pointing this out, because... And it's not moving, and I know why. Because when it starts off, it's already at the origin. So the cloud done is already true. So it literally does this first home check, and it's done, and then it stops drawing the cloud. So I need to actually start drawing the cloud and then go into that while loop. So let's have a look here. Why? Is there an error? But this takes place without the cloud done. Oh, I see. We never even called a cloud. Okay. I think I actually did correct a mistake, but I corrected it despite the fact that that mistake actually didn't happen. But there you have it. We have a cloud, and now the cloud is done. The program has exited. That is pretty awesome. So now we need to get into doing something a bit more interesting. So you see these cloud semicircles here. To make it a bit more interesting, these should be always a bit different. That will add some uniqueness to the clouds. So if we go size equals to random.randint, and if 5 is that size, we can go 3 to 7, maybe. And then always do the semicircle according to size. That didn't look that different. Size. Because we did not, we picked one single size at the beginning, so this needs to actually go in the loop. Copy. And so now the random is going to be generated. Yep. Pretty good. So now we have unique. We don't have realistic clouds, but at least we've got unique clouds, which is a step up. And what I'm going to look to do next is to sort of flatten the cloud structure. Instead of going in a circle, we should be going in an ellipse, and that's going to look a whole lot more like a cloud. So this is where we can play around with the adjust turn function. And what we can do is we can start with a heading, and the heading is basically turtle.heading, and it measures from 0, from flat here, going anti-clockwise. And we take the turtle heading where it is, and we can have, instead of having turtle.left 30, we can have sort of a random turn. So we can have rand turn equals to, I'm just going to go from 1 to 10, and I'll explain why in a second. Rand turn equals to random.randint 1, 10. And then I'm going to multiply it, and I'm going to multiply it by different factors. And you're going to see what that looks like in a second. So we can simply say if heading is bigger, equal than, say, 50. And I think a good idea would be to start with a tilt. So to start with 50. So when we're doing the cloud, we can go turtle dot left 50. And so when we start off, we can have a sort of gentle turn. If heading is bigger than 50 and heading is less equal to 140, we can turtle.left rand turn and maybe multiply that by 2. And then have, say, 3 more different conditions for what can happen. Now, I don't think it matters if I use if or elif, and I'm just going to cover the rest of the possible range. So if it's bigger, because 140 is included there, so if it's bigger than 140, so this is sort of the side edge. If the turtle's on the side, we are going to have to bend it a whole lot more. I'm just going to crank it up to 10. And if it's in the next range, so this is 220, so if it's bigger than 220, and if it's going up to, say, 270, we can go with 2. And if, so 270, it basically means that 270 is facing down. So it means when it's on the bottom, and when it starts facing back up, then we want to essentially slow it down a little bit like that. And that's going to go less than 50 and bigger than 270. All right. I just want to see what this is going to look like. Ouch. Let's try this again. So as you can see, when it goes sideways, it bends really quickly. It doesn't go down. But these, the flat ones, should be going around for much, much, much longer. Oh, I think it's the turn.left at the very start. So let's have a look again. Are we going to have a cloud? Or not? Okay. So I think I need to change that. Instead of turtle.distance, what if I can go if turtle dot x coordinate is, so if it goes back into the positives, bigger than 0. What is the error? Error, unorderable types. X coordinate needs a function bracket. Okay. Do me a solid. So this means that it can't cross that way. Yep, it'll just lock it in. And with this sort of home operation, rather than going straight to 0, 0, we can get it to face towards 0, 0. So the way we're going to do that is where was our home checking? If turtle, okay. So right here, we're gonna need to face towards 0, 0. And it's surprisingly difficult. I initially thought that just doing this, turtle dot towards 0, 0. I thought that this is gonna work, but it isn't. So we need to basically first turtle dot set heading 0 and then turn to the left towards 0, 0. So turtle dot set heading 0 and then turtle dot left. So what this does is essentially it sets turtle pointing in the neutral direction, in the 0 direction, and then points towards 0, 0. It only works this way. It's a quirk inside turtle. That's just the way it is. So now that we're pointing towards 0, 0, we can cover half the distance and draw a big dot. And that's going to look pretty neat, I reckon. So instead of going to 0, 0, we can basically turtle dot forward and turtle dot distance 0, 0 over 2. Hopefully that's gonna work. I don't know if maybe it's gonna produce a non-integer value, and if turtle dot forward has to have an integer, but we're gonna find out. And then we're gonna go turtle dot dot, which is gonna be a dot the same as the distance to 0, 0. So I really should have made a variable called distance, but let's have a look. Well, that was a sort of tiny circle in the end, but that's a pretty realistic looking cloud. I like it. Yeah, because I see. So we can actually, let's just make that variable. Distance equals to turtle dot distance 0, 0, and then we can make that distance over 2. And then use that original distance to make the dot. And that's a big cloud. Will it come back? Yes, it will. Beautiful. Okay, I am going to leave it at this, and you guys can figure out how to draw multiple clouds. I think this has been the longest tutorial in the series, and it's not for no reason. Actually, this is a relatively complex algorithm, but I enjoyed solving it, and I hope that you guys could follow along, and I'll see you in the next challenge.